Morning, guys. Hope you're doing well. Sorry that we have to do this today, but that's how it goes sometimes. Uh, Today we're going to talk about two things, what we call the midpoint formula and the distance point formula, and talks about looking at two different points on a coordinate grid and either finding out what's the distance between them, if it's kind of on a diagonal, right? If it's totally horizontal, totally vertical, all we'd have to do is count the units. But if it's diagonal, it might be a little trickier to tell. And then the other thing that we're going to do is find a point that lies directly in between 2 points and where exactly that should be. So first, let's start with the distance thing. So on this grid, I've got these 2 points. They're drawn at the -3, -2 coordinate that you see up above, and then 4, 2. So I can't, if I'm going to draw a line between them, and I wouldn't necessarily have to draw a line, but the question is asking how far is this distance here? There's really two ways to solve this. And the first way is based on something that you've already known, which is the Pythagorean theorem. So if I've got 2 points on a coordinate grid and the coordinate grid has all these vertical and horizontal lines, I could create a right triangle like this. It goes from there to there and then goes straight up. And the reason I might want to do that is because these vertical and horizontal lines, the legs of this right triangle, are really easy to count. So this side, it looks like it is a total of 4 units. On this side, let's see, that's a total of 7 units. And so therefore, I can take the Pythagorean theorem and say, well, 4 squared, one of my sides, one of my legs, plus 7 squared has to equal that distance that I was looking for, this distance between the two red points. So this would be 16, this would be 49, and altogether 65. So c squared equals 65. So therefore, take the square root of both of those. C equals the square root of 65, which should be just over 8, right? Whoops, 65. Okay, so that's one way to do it. It's just to take a look at the visual of it and create this right triangle and use the Pythagorean theorem that way. What I have up here, though, is something that we call the distance formula. And it's a trickier one to memorize, but it works really the same way this does. It's based off of this Pythagorean theorem. So here's what it says. It says you look at the x values of these 2 points. So remember, this one is at 4, 2. So if I'm looking at the x value there, I'm looking at 4. Oops. And this one is at -3. That's my x value, -2. Okay, so this x2, let's say this is the first point. We'll call this point number 1 over here and point number 2 over here. Okay, so this is x1 and x2. That would make this y1 and y2. And so that's what we're going to use to fill in here. Okay, so if I'm looking for x2, that's -3. We're going to subtract away the other x, which is a +4. So -3 minus 4 squared. Well, -3 minus 4 squared is -7 squared. I'm just going to show you right now, I had a 7 squared down here. I know this is a -7, but it's not going to matter when I square it. That's going to be a positive value. What that's really doing is saying I'm taking the distance from here to here, which ends up being 7, and squaring it. The same thing happens when we look at this y2 minus y1. y2 is -2 minus y1, which was 2. And when we square that, we end up getting -4 squared. Hey, look at that. We had a +4 squared down here. And again, it's not going to matter. I'm still going to end up getting the 49 and the 16 just like I had down here. And then I'm going to take the square root of all of that, just like we took the square root of all this. This distance formula is really just the Pythagorean theorem kind of in reverse. Okay, so it's good to memorize this, But if you forget how to memorize it, you can basically just think through the Pythagorean theorem and say, well, what's the distance from here to here? I'm going to square that because that's one of the legs. What's the distance from this y to this y? I'm going to square that because that's one of the legs too. Okay. Let's see how we could use this in an application. So here's a quadrilateral. The question says, is this really a rhombus? So we need to know a little bit about a rhombus. A rhombus, in order for it to be a rhombus, the characteristics say all the side lengths have to be the exact same. Okay, so in order for me to really determine this, and I'd look at that and say it might be, but I'm not quite sure, I would need to measure this side, and I'd need to measure this side, and this side, and this side. And if they are all the same, then I know it's going to be a rhombus. Okay? If I find any two that aren't the same, then I know right away it's not going to be a rhombus. So again, you got some options to do this. Let's say we want to find the length of PQ. Well, I can just form a right triangle out of that and know that this side is 3 units and this side is, looks like 5 units. And I do the Pythagorean theorem. I say, well, one leg squared plus the other leg squared has to give me that last side, PQ in this case, squared. So I'd have 9 plus 25 is a total of 34 equals C squared. So this measurement right here must be the square root of 34. Okay, I could do the same thing if I'm looking for QR. I could create a right triangle here with QR, and I could try to solve for that and see if I get square root of 34. But instead, let's try to use the distance formula. And the distance formula, remember, looks like this. So as we use the distance formula, and at first you're probably looking at this going, I don't want to use the distance formula. I already know the Pythagorean theorem. I'm just gonna use that. That's okay, but I think the more you get used to it, the more you'll find this is kind of convenient. Okay, so I'm going to say that Q is going to be my first point, R is going to be my second point, and so let's start with the x values. The x value of this point is 3, right? I'm going to plug in a 3 there. The x value over here that I'm going to subtract away is 1. So this first section is going to be 3 minus 1, and remember all of that is squared. I'm just going to do that right away. 3 minus 1 is 2, square it, 4. Okay? And we're going to do the y values. The y value over here is a negative 2. And we're going to subtract away this y value, which is a positive 3. And all of that gets squared. And so we get negative 2 minus 3 is negative 5. Square it, that's 25. Okay? And I'm adding those two things, and remember all of that is underneath this radical. So the distance is square root of 29. So if this was square root of 34 and this is the square root of 29, whoops, not 92, 29, then I can say for sure that this must not be a rhombus because the sides are not equal length. Okay. Now you might not be able to get that the first time. There's going to be some shapes as you're determining this sort of thing. You might have to do the side length for the third side and the fourth side to really verify the entire thing. Okay. But the two ways to do it, and they're based on one another, is to either just draw a triangle and use the Pythagorean theorem, or use that distance formula, which is really the Pythagorean theorem in reverse. Okay, let's go over to the next thing, which is the midpoint formula. We use a midpoint formula to find a midpoint, which means if I've got 2 points, in this case negative 2, 3, let's plot that on the grid, and 4, 7, there's 4, and I believe that's 7. The question is, what's the very middle point? If there's this imaginary line here, I would say my middle point is somewhere around here, right? Does it line up exactly on a grid line? So it's a nice even number like, oh, I don't know what's close to that. It looks like 1, 5 is pretty close to that. Does it line up exactly with 1, 5, or is it like 1.1, 5.3, something like that? Well, we can find the midpoint very easily. I would like you, though, to see if you can figure out on your own, come to a conclusion based on this link. I'm going to put that in Google Classroom for you. I want you to figure out what's going on here between these 2 points and see if you can tell me how the midpoint is determined. I'll show you what that looks like. When you click that link in GeoGebra, you come to this, and it allows you to take these points and drag them wherever you want. So here's point A, here's point B. So for example, if I put point B right there on 8.3, and I put, move this over to 4.3, I can go down here and say show the midpoint, which we can tell is going to be at exactly 6.3, right? There it is. But now if I move B, it's going to move that midpoint along with it. As you do this, just play around with this for like, I don't know, 2 minutes. See if you can determine how that midpoint, the value of the X and the value of the Y in that midpoint is determined. And I will give you a clue. Look at the X's, look at the Y's in your A and B points, and then come back here and look at the new midpoint. Okay, you can use this eventually, that little thing and this little thing, but I would rather have you see if you can come up with it on your own. So pause this video now, and then we'll go on. You may have already come to this conclusion that what's happening here between these 2 points is that we are taking the X values, so in this case 4 and 11, and we're finding the very middle value between those 2 points. In other words, we're averaging the X's. The average of 4 and 11 is 7.5. And then we do the same thing for the Y. The average of 3 and 3 is 3. Now this is an easy one to see. It's a little bit more difficult when we've got strange numbers like this. But if you look at this, 4 and 8.69 has an average, if I would add these 2 things up together and divide by 2, would come to 6.34. The same thing happens with my Y values. If I add 3 and a negative 5.97 and divide by 2 to find the average, I would get a negative 1.48. It doesn't matter where I drag these points. The midpoint coordinates are always the average of the XY coordinates of those outer points. Okay, so coming back to this, I could, in order to find the midpoint here, I could actually draw a line, I could find the distance, I could try to do that and match this up. But really, all I need to do is look at these coordinates and say, what's exactly in between -2 and +4? Well, if I add -2 and +4, I get 2, and divide that by 2, I get 1. That tells me my X value is going to be 1. Whoops, that is ugly. Let's start over. My new coordinate of the midpoint is going to be 1. And then if I do the same thing for the Y's, I look at 3 and 7, say let's add those up and cut it in half. 10 divided by 2 is 5. So that point is at exactly 1.5. Okay, and I said it was pretty close to that, but I couldn't tell for sure. The reason this works, by the way, if I look at my X value of -2, which is right here, and I just draw a big line here, and I draw a line at 4, what I'm doing is looking for the exact halfway mark between those two. That's why this whole averaging thing works. That tells me my X value here of my midpoint. And then the same thing happens with my Y values. Here's my Y value of 3 and my Y value of 7. And I'm taking the average right in between that. And so where those line up is going to give you that midpoint right there between those two numbers, or between those two coordinates. Okay. Now, again, I would like you to pause the video for just a second. Take a minute, okay? No more than a minute. But see if you can find, just think about what we've done here by averaging the X values and averaging the Y values in order to get a midpoint. How would I write that mathematically? How would I show mathematically what the midpoint formula is? Okay, pause the video, give it a shot. I'd be pretty impressed if you came up with this. If you didn't, that's okay too. But here's what the midpoint formula actually is. And this should make sense based on what we've just talked about, how we take one of the x values and another one of the x values and we average